So we're going to cover a couple different topics, kind of maybe a little bit scattered topics, but they're interesting and they tie in nicely with what Angelica was covering in her sessions and what she'll cover in her follow-up sessions as well. So let's get started. What we're going to cover are Jupyter Notebooks and using them for threat hunting. The kind of a little bit more in depth on the Defender for Threat Intelligence, the Risk IQ acquisition that Angelica had been talking about. And then the last part is Defender External Attack Surface Management, which is a pretty cool capability. I think everybody will like learning about that one. And of course, we got demos for all this stuff. All right, so if we talk about Jupyter Notebooks and threat hunting. So for those of you that may not be as familiar with it, what is a Jupyter Notebook? So to begin with, Jupyter Notebooks are not something that Microsoft concocted themselves. They are something that's been around for a while. And Microsoft just recognizes that they are often used in the security community because they allow you to tie pieces of code together in a kind of a sequenced pattern and allow you to run that code sequentially and perform different tasks in a methodical way. And it can be used with a number of different languages. So, for example, you can use Python, right? That's where the name Jupyter comes from. The PYT in Jupyter comes from Python. And that's typically what many of the notebooks that you're going to encounter are written in. But you can also write them in KQL or PowerShell or kind of just any language that suits you. The great thing about notebooks is that they can also serve as documents. So while you can run a notebook and it'll execute code, it'll also do things like perform equations, it'll create visualizations, it'll create narrative text. So people use Jupyter Notebooks for things other than security and threat hunting. It just happens to be something that proves to be pretty useful in the security world. As I mentioned, it is used in different scenarios, things for data science, stock market predictions, astronomy, but it is also good for cybersecurity. One of the nice things, and I'll kind of show you how this kind of pieces together, is you can also use the notebooks as a training method for your maybe new SOC analysts. So if you have somebody come in that maybe has not done a whole lot of threat hunting or investigations in their career, you can use notebooks as a way of guiding them through the proper process for doing the investigation so that they understand how your organization does things in a methodical way so that they're not just learning on the fly and kind of guessing at how to do things. You can document what you want them to do, and they kind of learn the right process. So they're very, very good at helping you to ensure that the same type of processes are followed in your SOC. So you can kind of think of notebooks. If any of you use OneNote, Microsoft OneNote, I love OneNote. Jupyter Notebooks are like OneNote on steroids. So like in OneNote, you can record your voice, you can draw pictures, you can type stuff, you can insert diagrams, you can do all kinds of stuff. With Jupyter Notebooks, you can do even more. So let's actually get into what these things do. Some of the things are some of the uses that you can put Jupyter Notebooks to within Sentinel. So storage of investigation artifacts. So indicators of data persistence, being able to repeat activities that you're investigating. So you're able to collect and store evidence and different types of collateral that will allow you to improve your response time the next time something like this occurs. So once you've collected this information about which IP addresses are being used by an attacker, what file hashes they're using, what certificates they use, whatever it might be, you can store that within the Jupyter Notebook, and then it becomes a repository where you can refer back to. Obviously, you'll want to put those artifacts also into Sentinel, into like your IOCs and things like that. But also from a documentation standpoint, it's good to have it in these notebooks. As I mentioned, they can be very interactive, so you can store scripts and you can store the results in line for investigation. So as an example of why that might be useful, think of a situation where you know that an attacker has breached your organization, and what you want to do is find out perhaps which machines have been compromised. And so you could run a script within a Jupyter Notebook, and the script might say something like, give me a listing of all the user accounts that logged in at 2 o'clock this morning, right? So that little block of code will run, and you'll get an output of those users. And then from there, it can be used as input for the next block of code. So you can then say, okay, for the users that were identified as having logged in at 2 o'clock in the morning, now show me which machines they logged into at that time. And so you can start to narrow down which machines may be compromised, and start to figure out, where the attackers have moved within your environment. So they can become a way of storing the information as you identify it. And then at the end, what you can do is say, send all this information that's stored in line in this Jupyter Notebook, make a copy of it, and send it to teams. Right. And so within Sentinel, you have the ability to create a team for each incident that is generated in Teams, right? Or in Sentinel. And so you can say, send the results of my run of this Jupyter Notebook over to Teams, and then it gets stored in Teams. So all your artifacts, all your information is stored in one location. So it can be really useful for that sort of thing. Because it can work with different programming interfaces, different languages and stuff like that, it has usefulness for people that may be more comfortable with one language or another. And like I mentioned before, it can help you to train and standardize the way that you do investigations. So how do you set up a Sentinel notebook? Sentinel notebooks are dependent on an Azure machine learning workspace. You obviously have to have the right roles in Sentinel. You have to have at least Microsoft Sentinel contributor to launch and save notebooks. And then if you want to create a new Azure machine learning workspace, you have to have owner or contributor role at the resource group level. So when you go into the Sentinel Notebooks tab or blade, you get a drop down over here for configuring Azure Machine Learning. You'll create a new Azure Machine workspace. You can also use, there's a Synapse option as well if you want to use that. But for getting started, let's use a new Azure ML workspace, and it'll give you the option of using a private endpoint or a public endpoint. Unless you have a specific reason why you need to use a private endpoint, if you need to connect to a private endpoint through a virtual network or something like that, or a VPN. If that's a requirement from a security perspective, you can do that, but it generally is easier to use a public endpoint to avoid any kind of firewall issues. So you'll create this new Azure Machine Learning workspace. And that Azure ML workspace is where you'll set up compute resources that'll be used to run your notebook. So notebooks have two components. They have a browser-based interface, which is what you see kind of down here, where you enter and run your queries and code, and where you see the output of that code. But there's also a kernel, which you see referenced here, and that is what's responsible for parsing and executing the code itself. So one thing that you have to do is create a compute resource. So you see here we have compute instance, and it says that there's no computer resource. When you click on that, it'll ask you to create a compute resource, and it'll give you options for what type of virtual machine you want to create that will be responsible for running these for running the compute processes for this workspace. And you can define, just like you can with an Azure VM, what type of what size VM you want to use, and how that compute target is optimized, right? So it might be memory optimized, it might be processor optimized, whatever it is. You can make a determination about what is most appropriate for how you're going to be using this machine learning workspace. So you create that, and then if you want to create a notebook from an existing notebook, the easiest thing to do is just clone the notebook. And so what that will do is give you a pretty good starting point for what the structure looks like. If you just want to learn how to create notebooks, this is a pretty easy way to begin learning. So you rename the existing built-in notebook, you save it to your newly created machine learning workspace. And then once it's cloned, you need to assign the compute resources that you created in the previous slide to that notebook. So how do you do that? When you look at your compute and kernel resources here, by default, when you get things started, you'll see that they are in a stopped state. So your compute resource is in a stopped state, and your kernel is not connected. So if you want to start the VM that is running your ML workspace, you click Start Compute. It'll turn that on, and then you connect the kernel. So the kernel is shown here in the drop-down once the computer is actually started. And so when it's all started, ready to go, it's going to look like this. You're going to see a green dot by the compute instance. You'll see that it's running, and then you'll see that you have connected a kernel. And there are different types of kernels, different versions of Python that you can use to run your code. And the way that you can tell the stuff is working is the difference in the color here, right? So you have the blue means everything is running and operational. The black means it's kind of in a stop state. So that's how you get things going. When you look at your machine learning workspace in your Jupyter environment, when you create a notebook, you have a default workspace structure, and it looks like this by default. So let's say your name is Megan Bowen. You're going to have this utils directory. You're going to have you'll have a notebook that you configured and you're starting to work with. Now, this structure is going to be important for when we want to add additional notebooks to our Sentinel instance. Now, why would we want to add additional notebooks? So if you go to the product team's GitHub repository, they have notebooks stored in GitHub. Now, the stuff that they have stored here, the ones that you see listed, these are not all included in your Sentinel instance by default. So for example, the MITRE map notebook, different scenario notebooks, machine learning notebooks, you're not going to see those by default in your Sentinel instance when you spin it up. You see maybe 25 notebooks, but there's a lot more that are listed here in the GitHub repository. So the question becomes, how do you get these into your Sentinel repository? And I'll walk you through this in the slides, and then I'll walk you through it in real life and how it works. So the first thing you do is you actually open a notebook. So you're going to create your compute resource, you're going to connect your kernel, you're going to open a notebook, and then you just copy this bit of code that's found in a learn.microsoft.com document. I'll show you that. You copy this bit of code into any notebook. It doesn't matter what notebook it is. You just copy this little section of code and hit the little button here that says run, right? So you'll do plus code. You'll enter this bit of information so that you can clone this repository down to your machine learning workspace. You click run, and it'll copy all the notebooks that we saw back here. It's going to copy all those notebooks into your machine learning workspace. And you see this this process taking place here. So it's copied all the objects down, and it says it's done. So what it does then is it creates a new structure in that machine learning workspace that we were looking at. So they get stored in this Azure Sentinel NB directory. So you remember we had a utils directory, and we had one of these Jupyter Notebooks in our original scenario, but now notice we've got the ones that were in the GitHub repository. We've got the Azure Hunting, the MITRE Map notebooks, scenario notebooks. We've pulled all of those down into the machine learning workspace. That's great, but they're still not going to be visible in Sentinel yet. So how do we move them from the machine learning workspace over to Sentinel? The way we do that is, let's say we select a specific notebook that we want to copy over, and there are obviously ways that you can automate this, but what I'm going to do is show you how to do this one at a time so that you at least understand what's taking place. So let's say we want to copy this guided investigation, anomalous users generated by isolation force. We want to copy that notebook into the Sentinel workspace. When you highlight this this notebook, you're going to get an ellipsis on the far side here. And that ellipsis will give you these options. When you get these options, you select move, and then you select the Megan Bowen notebook, which will drop it at a higher level than the Azure Sentinel NB, right? So it's going to drop it at this level, and that will make it visible in Sentinel. So when you go into the My Notebooks tab in the Notebooks blade in Sentinel, what you'll see is the notebook that you just copied over from your machine learning workspace. It'll be visible there. There are also ways that you can use that same process for updating notebooks. So from time to time, the product group will update the notebooks with additional logic and clean up the code and stuff like that. So there's another way that you can copy the updated notebooks over to your Sentinel workspace, but we're not going to cover that right here. So when you run a Jupyter Notebook, you can run each step of the notebook one at a time, or you can run them in blocks. So you can run everything above this this cell, or you can run everything below this cell. What you can't do is say, I'm going to run this cell, and then I'm going to just skip down 3 and then run that next cell, and then skip down 2 more and run that next cell, because very often these are structured in such a way that one cell feeds the next cell, feeds the next cell, and so if you run them out of order, or out of sequence, I should say, they'll fail because they don't have the right input from the previous cells. All right, so let's take a look at how we move these notebooks to Sentinel from your machine learning workspace. So let me first show you what I was talking about here. So here is the repository where the Sentinel team keeps all these notebooks. And as I mentioned, they have the ones for MITRE and different scenario notebooks. So let's take a look at one of these, like here's one for automated incident triage, automated notebooks incident triage, okay? Now, if I go to my Sentinel workspace, if I type in triage, I don't have this automated notebook incident triage, okay? So I have a couple that are for that reference triage, but I don't have that automated notebook incident triage. So what I want to do is I want to get it over here. I want to get it over here so that I can actually run that notebook. And so if I go to this is that code that I was telling you about, which is located here. So if you go to download all Microsoft Sentinel notebooks, you get that block of Python code. You just copy it, go over here, you create a new block of code, you copy it in, and you run it. It might fail because I've already got the structure created here, but let's give it a try. Okay, so it's just fixing the deltas and it's done. Okay, so, oh, it's not done. Okay, so now what I've got is the latest version of these notebooks copied over into this Azure Sentinel NB directory. What I want to do is get it over here. So this is where my Sentinel notebooks are showing up. So for example, if I look in my Sentinel notebooks, affected key credentials, Azure Kubernetes service, affected key credentials, Azure Kubernetes service. So that's where they're showing up, right? So I need to get, let's say, let's go to one of these automated notebooks. Okay, let's do this guided hunting Office 365 exploring. Okay, so what I do here is click, go move. I move it to my directory. It moves it over. Okay, now what I should expect to see when I go to my Sentinel notebooks is I should see a notebook called Guided Hunting Office 365 Exploring. And so if I refresh, I should see something about Guided Hunting Exploring. Guided Hunting Exploring. Maybe I copied it to the wrong spot. No, it's in the right spot. It might just take a second to show up there. We'll come back to that in a minute. It will eventually show up down here, Guided Hunting Office 365 Exploring. It might be pulling it right now because it's taking a little bit longer. Yeah, it'll get there. In any case, once it shows up in there, then I can go in and get it started. I can start the notebook itself. Now, what you'll notice here, in this instance, I've already started my compute instance just because it takes a couple minutes to get started and get running. But you see, I've got my compute resources going. I've got my Python kernel, and you notice there are different types of kernels that you can use. In this case, I'm using the Python 3.8. And then what it tells me here is that because of the way things get rendered in Azure Machine Learning, it says you might want to run this in Jupyter Lab or VS Code. In order to do that, what I do is go over here, go to Editors, and then Edit in Jupyter Lab. So it should, oops, I think I did the wrong thing there. Continue, that's what I want to do. And it's going to start in just a little bit different interface, right? So from here, you notice what I can do if I want to run code, right? I've got the ability here to query data in Sentinel, verify my Sentinel settings, and it's going to do all these different little elements of this guided hunt. And each of the phases of the hunt will give me output that will then feed into the next phase. And at the end, what I can do, if I go all the way to the end, once I've got all this information documented, then I can add another block of code in here that sends all this information over to a Microsoft team. And then I have all this information documented. It's a great way to document everything that you're doing. So let's see if it's copied over yet. Yeah, I probably copied it to the wrong place, but in any case, let's try it again. So guided hunting, MITRE map. Let's do anomaly lookup. Maybe I moved it to the wrong one. Well, I'm not sure what's going on. I can't remember which one I moved. In any case, this is where it will show up when it works correctly. For whatever reason, I've got it broken right now, but this is where they'll show up, and this is where you can run them from. Like I mentioned, here's where you configure your Azure Machine Learning workspace. So you can create a new one. You can set a default one. If I want to navigate to mine, it takes me to the place where I have the notebooks stored and where I can start working on them. There's a whole bunch of other stuff I can do here. So part of the use case for this threat intelligence, there's actually a number of different use cases. So you can do things like, besides just threat hunting or investigating an incident, you can do things like intelligence analysis and cybersecurity research. So as a partner, one of the things that you can do is actually make that part of the offering that you sell to customers, is that you'll do cyber threat intelligence, on their organization, right? And against the attackers that are typically their adversaries. So depending on what type of organization they're a part of, they may have a specific set of adversaries, maybe North Korea or some group in Iran or Russia or whatever it is. They may be specifically targeted. And so it may be useful to them to know specifically how those attacks are going to be carried out. And that's where this MDTI can come in handy. So some of the things that you get in Defender TI, besides the stuff that Angelica was talking about, the things like domain listings, IP addresses, I think she mentioned file hashes and things like that, is that you get articles. So these are not just blog articles that talk about general threats, but very specific indicators of attack. You can do some very sophisticated investigations, including things like doing whois lookups, looking up SSL certificates, what kind of cookies are being used by attackers, a whole bunch of different elements of attacks that we see. You can group these into projects. So if you're doing an investigation of a particular threat actor, you can group these pieces of evidence into a project so that you know that these are all related to sort of the same thing. And it can help you to understand, when something happens, it's all part of this overall methodology that this threat actor uses. And then there's this reputation scoring capability as well. So looking at the internet infrastructure that attackers are using and investigating, is this domain a trusted domain, or is it just a garbage domain that's being used for command and control or things like that? So the way this works is that essentially Defender for Threat Intelligence graphs the internet every day. And so it does that by means of things like web crawlers, scripts, random interactions, active and passive sensors. But the thing to keep in mind here is that this has to be done through the eyes of the attacker. And the reason this has to be done this way is that attackers will know when they are being scanned by a bot or just being acted upon by a threat researcher. And so during a threat campaign, threat actors are going to use different types of browsers, different versions of OSs. They're going to target different regions of the world. They're going to target specific IP spaces. And so in order to understand how the attacker is trying to breach your organization, you have to understand how they act. So we act like the attacker. We use different browsers, different desktop versions, different mobile versions. We use proxies so that it looks like normal user interaction instead of just a bot performing activities against their infrastructure, right? Because they're going to be looking to see if they've been outed, right? To see if they've been detected, and then they'll move on to some other piece of infrastructure. But we want them to stay where they are so that we know what to do about them. And so there's let's actually just pop back into the demo, because so Defender Threat Intelligence, this is and this is different from what Angelica was talking about, the kind of built-in Microsoft Threat Intelligence. This is Defender for Threat Intelligence, and this allows you to look for different elements like I was talking about, the WHOIS information, certificate information, cookies, different trackers. And then here's the articles I was telling you about that tell you about different threat actors and things that they're engaged in right now. Here's some very current stuff: APAC-based Android users targeted with a banking Trojan spy app, right? So as one example, if I go in here and for the IP address on threat intelligence, I can go in and say, whoops, let's just do it all. So I look for that IP address, and it comes back and it tells me that this IP address is hosted in Russia. The first time it was seen was February 14th, 2023. Most recently, it was seen sometime last week or 2 weeks ago. What's the network block that it uses, the ASN that it uses, the organization, and then what do we know about it, right? So here's one of those garbage domains, right? So when we see these types of domains, this is typically like command and control stuff, right? They create these garbage domains that tells us that these are what they're using for command and control. So if I see this type of name connecting to, or my machines on the inside connecting to this domain, I need to be concerned. And so I might add this to a project, right? I can add it to a new project that has to do with whatever I'm calling this threat actor. If I go back here and I look at something else like Canary, let's do Cobalt Strike. That's a good one. So everybody knows what Cobalt Strike is. If you don't know what Cobalt Strike is, it's a threat. It's a red teaming tool, basically. So they'll use it to do pen testing and things like that. But attackers will also use it. And so we get some articles, different attackers that are using, Cobalt Strike, and we get some information about what type of attackers are using that. So if we see indicators of Cobalt Strike in our environment, we can narrow down kind of what threat actor might be acting against us and figure out how to counter them. We can see which hosts have this component acting on them, which IP addresses have Cobalt Strike on them, and so on. So that's just a super high level view of Defender Threat Intelligence. Again, I'm out of time. The last thing I'll show you is the external attack surface management, and this is another very cool tool that that we're using now. So what this is doing is taking the internet and saying, tell me what my organization looks like from an attacker's perspective. So in other words, if I was an attacker, what would Microsoft.com look like to that attacker? And so I would put my domain name in here as a seed, and then what it will do is then go out and look at all of my all the external facing assets that my organization has. So it's going to look at the domains that are associated with my name, the hosts that are externally accessible, what certificates are accessible, what IP blocks are seen, a whole bunch of information. And it tells me this is what your attack surface looks like from an attacker's perspective. So these are the things that an attacker is going to hit first when they try to attack your organization. So you're saying, I want to know what an attacker sees when they're trying to attack Contoso.com. And so this is what gives you that visibility into your customers' external attack surface management. And then what you can do with this is determine things like, what is your attack surface priorities? What are the things that you need to take care of first? How do you secure them? What are the sensitive services that are showing up in the cloud? Um, you got a lot of Amazon hosted resources. We got some Cloudflare resources. When are the SSL certificates expiring, domains expiring? These are all things that attackers care about and will try to compromise if given the opportunity.